In this video, we're going to be wrapping up chapter 1. This is the end. So, like I mentioned in the previous video, we're going to continue talking about absolute values. However, today we're going to extend it to the idea of absolute value inequalities instead of just absolute value equations. So, I'm going to start by just going over some of the basics just to get an idea so you guys can picture what this looks like. So, I want to graph the absolute value of x is less than 5. Okay, so what does that mean? Well, I want to be less than 5 away from 0, right? So this is a collection of all the values that are less than 5 away from 0. Well, that can happen in two ways, right? You can go up to 5, or you can go down to -5, right? And that will be the collection of all the values that are less than 5 away from 0. Or in this other case, less than or equal to 5 away from 0. All that means is they can extend up and actually be 5, or extend down and actually be -5. But what I want you to notice is when you have an absolute value less than a number, you are collapsing down and being between those two values. So here we're looking for all the values of x between -5 and 5. And you can write that like this. So for this example, I would rewrite this to be scrunched in between the positive and negative of that number, or in this case, less than or equal to. I'm scrunching it in. So when you're less than, you are restraining yourself between those two values, the positive and the negative. You're scrunching yourself in between there. Okay? So let's take a look at how to solve some of these in an actual equation. All right? So solve and graph to get the solution. So again, we have an absolute value that is less than a number. So being less than a number, it means we are condensing it down. We are restricting ourselves in between the negative of that number and the positive of that number. So the cool thing about solving these is these are the component inequalities that we dealt with a few lessons ago. So now, as I'm solving for x, all I have to do is do the same thing to both sides, and I've got it. So, for example, I need to subtract 3. Well, I just subtract 3 everywhere. I need to divide by 4. So, I get -2. The x is by itself, that cancels. 2 over 4 is the same thing as 1/2 or 0.5. So what this is telling me is I have -2, I have 1/2, and again, my absolute value is a less than, so I'm scrunched in between there. I'm scrunched on the inside. Let's try this next one. Again, less than, and in this case, less than or equal to, but it's going to be the same thing because it's less than. It is restricted in between the negative value of that number and the positive value of that number. I'm bounded inside. And now I just have to go through the steps to get the x by itself in the middle. So when I add 4, I have to add 4 everywhere. When I divide by 3, I divide by 3 everywhere. And again, please leave as a fraction. Now, negative 4/3, to plot it, you can type it in the calculator, and it is 1.3, or negative 1.3 repeating. But again, please, please, please leave it as a fraction. Only type it into the calculator so you know where to put it on the number line. Now here we're going to be using solid circles. So negative 1.3 repeating, 4, and again, because the absolute value started as a less than, it means that we are restricted within those values. All right, so let's take a look at the opposite side of this. Okay, so the opposite side is, what if I want my absolute value of x to be greater than 5? So that means I need all the values that are more than 5 away from 0. So what does that look like? Well, more than 5 away from 0 would look like that. However, there's another half to it. More than 5 away from 0 could start down here and extend downward. Okay? Or in this case, you can always have the or equal to piece added in, and then you would just be dealing with solid circles. So to write these isn't quite as fun or neat as writing the less than ones, but essentially what you need to picture is greater than means you're extending outward, okay? So what that means is you're solving the inequality here. You want to be less than the negative or greater than the positive. You need to be extending outward this time, all right? So you need to be able to write it, that you are less than the negative or greater than the positive. In this case, again, you kind of have the or equal to piece involved. But if your absolute value is greater than, you're extending outward, you're extending away to be more than that distance away from the center. All right, so let's take a look at what this looks like. So solve and graph this one. All right, so again, the thing that I pay attention to first is that it is a greater than, okay? So greater than means I am pushing outward, all right? So pushing outward, that means I'm going to be less than the negative or greater than the positive. I'm pushing out, all right? And now I just solve like I always would. So subtract 6, divide by 2. So x is less than or equal to negative 8. Or subtract 6, divide by 2. Or greater than or equal to 2. So let's take a look at what this looks like. Negative 8, and I'm less than that. Up at 2, greater than that. And again, this matches the conversation we just had. We are pushing outward because it is a greater than inequality. All right, how about this one? Well, again, I noticed it's a greater than. So what that's telling me is I need to be able to push outward. So what that means going outward, I want to be less than the negative or greater than the positive. And I wrote that wrong. I apologize. That should be a 15. And now I just start solving both of them. So I'm going to subtract 10 from both sides. 5x is less than negative 25. Divide by 5. X is less than negative 5. Or, when I subtract 10 from this side, 5x is greater than 5. Divide by 5. X is greater than 1. So, open circle down at negative 5, pushing left, up at positive 1, pushing right. And again, this visual makes sense because we've been discussing since the very beginning of the problem that it's a greater than absolute value, so it's pushing out. All right, so here's a fun little one. So just to get us thinking about what this looks like, all right, starting with number 1, absolute value of x equals 4. Well, if it equals 4, remember that was the case from yesterday. Okay, when it's just equal to, you're only getting those 2 points. All right. For number 2, absolute value of x is greater than 4. Well, greater means that you're pushing outward. So that's going to be this one or this one. But it's strictly greater than. So that means we should be having an open circle. So open circle, they did their best to show that with A. Oh, sorry about that. All right, number 3, less than. Well, less than, remember, is restricting it in. But it's less than or equal to, so that means we want the filled in circles that E has. All right, x is less than 4. So again, we're talking about being restricted within. But this time it's strictly less than, so we need open circles like B has. And finally, last one, greater than or equal to means we're pushing out, but we need the one that has the filled in circle because it's or equal to. That's going to give you C. So just a little bit of practicing between the 5 different situations that can occur when you're looking at these. All right, so finally, let's talk about the types of word problems that can arise when we're dealing with these absolute value inequalities. So, all of the situations that arise for absolute value inequalities are considered a tolerance. So by tolerance, it means how much variation are we willing to allow? And in terms of the calculation, the tolerance is going to be half of the difference between the min and the max, all right? Now, again, that doesn't mean much until we really just dive in. So let's take a look at the example. We want to cut a piece of wood to be 6 inches long, but we will use it if it's between 5.9 and 6.1 inches. Okay, so here they're starting us off with, we want this, we want 6, but we'll allow it to go down to 5.9 and up to 6.1. So if we were writing it as simply an inequality, that's really what we're looking for, right? We want the lengths between 5.9 and 6.1. However, there is kind of a cool way that we can write this. So the tolerance. So the tolerance, these two values, the 5.9 and the 6.1, those are 0.2 apart, right? So they're 0.2 apart. So the tolerance in either direction is 0.1, which again makes sense. Here we actually knew what the center was. So you could easily just say, well, from 6 up to 6.1 or 6 and down to 5.9 is 0.1. So here is a little bit more obvious. You really didn't need this calculation, but it's still good to know in case that information isn't necessarily given to you. But again, the tolerance is the allowance in either direction, the fluctuation you can have. And in this case, our fluctuation is 0.1. Now, the way to write this, okay, and I know it's already there for you, but I'm going to talk through it. The way to write this is you take your variable, so here, your lengths, minus what that center is, all right? So I'm going to pull it a little note here that is the center, okay? That's your goal, okay? Maybe that's another good word for this, is your goal value. It's what you really actually want it to be. We want 6. But how much can it differ? Well, we will be willing to accept it if that difference is less than 0.1. We're willing to accept that difference to be less than the tolerance. All right? So in all of these situations, and yes, there will be a couple on the practice sheet that you'll be getting, but the goal here is for you to be able to construct this. So the variable minus the center, minus the goal in absolute values is less than the tolerance you are allowing. So let's start from scratch, shall we? So you can see how this works. So in car racing, a car must meet specific dimensions to enter a race. Suppose that the desirable height is 52, but cars will be accepted as long as they are between 51 and 53 inches. Write an absolute value inequality to describe the cars allowed. So there's two things that we need. We need the center, or the goal. So here, what is the ideal car? Well, the ideal car is 52 inches. What's our tolerance? What are we willing to accept in variation? Well, we're willing to accept it to go down to 51 or up to 53. So if you notice, that's a tolerance of 1 inch in either direction. Or again, if you're looking above in the notes, you could say, oh, the difference between 52 or 53 and 51 is 2. Divide that by 2. That gives you the same 1. But in this case, again, you could just say 52 down to 51 is 1, 52 up to 53 is 1. So that's our tolerance. And now to write the actual equation. Now here I'm going to use h for height. So the variable minus the center, so the difference between our values and the goal value, we want that to be less than or equal to be within the tolerance of 1. And that's how we could write that as an absolute value inequality. All right. So again, some really good stuff here to wrap up the chapter, but that also means you may have some really good questions to come back to class with. So take a moment here, write that summary, please, of either reflecting or thinking about questions you have for me, and then we will wrap it up in class.